We are here today in the Deep Space 8K of the Ars Electronica Center that not only features fantastic high-resolution images, but also a tracking system, so the computer always know where our visitors are. Welcome to another episode of Home Delivery. Welcome to Inside Futurelab. And today I'm really pleased to welcome a colleague with whom I've worked here at the Ars Electronica Center since a long time, with Otto Naderer from the Ars Electronica Futurelab.
Hello.
Hello, Otto.
Thanks
welcome. And tell us a little bit about your key research subject that has a lot to do with the room that we're in right now.
I'd love to, yeah. Yeah, let's get this started. What I brought with me as an introduction is this little application that we can not yet really see on the floor, but when we start walking around, we see circles coming up when we get closer to each other and disappear when we get further away from each other. In order to make this work, we of course need to have some sort of a system that knows where we are positioned. And for this, we have 6 LiDAR laser rangers installed in the deep space here that track our movement. You can see we have little white circles underneath us that follow us wherever we go. And the circles that we create, they show something very specific, a specific basic of human interaction. What we can see when I come closer is that I enter a green circle. This green circle denotes a space around you, which is called the social space. That means when I enter this space, I approach you in some way. Might ask you a question, might even know you, and I want to come even closer to say hi. When I want to do this, I come into the second circle here, which would be now your personal circle. This is a circle where you would only allow people that you know well, maybe friends and relatives, to enter. You would feel uncomfortable when an unknown person approaches you that closely. And the next and final circle is the so-called intimate space, where we only get that close when we want to physically interact. I want to hug you, or you want to kiss maybe your wife. And these circles here show a specific field of research that's called the Proxemics. And these Proxemics I wanted to use as an introduction for my topic. These Proxemics.
One question for me to interrupt
Sure.
you, and also for the viewers at home, please feel free to send us, as every time, your questions in, and we'll pass them on to Otto. One question that comes into my mind
Sure.
here right in the beginning is, are these, every person, does it have the same kind of distance, or does this vary from people? From
It
person
is
to person?
evaluated over, I think, a big amount of persons, but it is also clear that these circles, they vary in size and in diameter, of course, depending on social and cultural context.
Mm-hmm. Okay, thanks.
Yeah. So why am I showing this? I'm showing this because it is a very good example that I can already obtain very valuable information just by analyzing the distance of 2 persons. If I come that close again, we can assume that we know each other well because we feel comfortable standing that close to each other. So by this, I can already say, given the distance between us, we know each other well, apparently. What does this mean for machines when we design interaction, human-machine interaction? A machine can already know by this principle how closely I can, as a machine, I can approach a human. I would also have to know, as a machine, this person I'm approaching. Does this person know me? So I can get even closer. But generally also, are persons around me familiar with my presence? Do they already see me walk around? Always as a machine. The next big topic as an introduction is space, like the public space, the space, 3-dimensional space that we use as humans. up to now, it is only us who use this space. It's only humans that walk around, maybe in animals, but we're not yet really familiar with machines sharing this space with us. Space, as we have already seen, tells a lot or gives a lot away of how we currently feel. Are we in a hurry? Are we relaxed? Do we need help, maybe even? So a lot of information is already derivable from just observing people. Can all see this when we just walk around outside and see how people even look. Yeah, also the face is, of course, a very, very valuable source of emotional information. So now this space that we have, and this space that is only used by us humans, is now continuously, it might be the wrong word, but machines enter this space more and more into our daily lives. We already know the advancements in autonomous vehicles, cars that can drive without a driver. We already face moving robots in certain environments. For example, we have already seen robots that are capable of autonomously measure a patient's temperature in a hospital, for example. So this key question that this all revolves around is how to admit and how to integrate machines into this space. And this is the key question of my research topic, algorithmic apperception. How can we achieve this? Because, of course, to have these machines weave into our space, they have always to observe the basics of human interaction. How do we approach each other? How do we interact? How closely do we interact? We've already seen this with Proxemics. And a very valuable information is that we require machines to not only sense this environment, but also to interpret it, to make sense out of this environment. It's not sufficient that we just have a distance evaluation. I would only need to know, do I know you, how close? And we often seen this.
Maybe just interrupt you shortly,
Sure.
because I get a couple of questions already in, and one kind of touches on the thing. It's not only the space that kind of tells the difference, so it's also we humans make up a lot of body language. So
Right.
how, or is that also another stage, and how you can incorporate? So it's not only space that tells a lot of this interaction part.
Sure, space is only, distance is only the simplest form, of course. Usually you would also investigate how to get additional information from a person. We can have computer vision, for example. We can detect the stance of a person. Is the stance standing relaxed, or is it an aggressive stance? We can already also use computer vision to derive emotions from the facial expression. We can derive an approximate age, gender from facial recognition.
But what does it also mean for the body language of the machine then? Because this is also, we humans have to feel comfortable with these kind of machines, not only in terms of how much
it works
distance
both
they keep.
ways, yeah, exactly.
So
But for a machine, this is very valuable information to, again, decide on, should I continue approaching this person? Because if a machine gets closer to a person and this person walks away and has like this defensive look, the machine would probably cancel this approach and would turn away from the person as they don't feel comfortable, apparently. So basically what we aim for in this is to make the machines perceive their environment as a human would. Only by that we can also assure a most natural interaction. What does apperception mean, actually? And I was browsing through dictionaries and I found these two definitions to be most fitting for my research topic. The first is conscious perception with full awareness. And this full awareness is, I think, the one, this part that explains it the most. We need the most possible awareness a machine can have by using multiple sensors to perceive this environment. And the next one is the perception that reflects upon itself. I like this because to me it means that we can also investigate towards artificial intelligence, investigate towards a possibility that we have this this perception by sensors, and then on top artificial intelligence that will constantly improve this perception of the world.
So this also means this kind of, when you connect it to this full awareness, also connected to neurosciences. So this like of kind of collaborate. Is there also kind of collaborations going on in terms of giving these machines this full awareness?
Yeah. I can also see this as a that they exchange data, for example, and by that gain additional knowledge or improve their ways of perceiving environment. Exactly. So the goal can then be formulated as algorithmic apperception investigates how to equip these machines to perceive their environment with the eye of a human. And that means to use many different sensors, of course, to achieve this. As a human would also, of course, use all available senses. Yeah, when we cross the road, we look for cars, we also listen for something closing in. That would confirm or at least makes us look twice if we're not sure. And another important point is, when we have that much information about the environment, about people around the machine, is to look for intention that can be derived from human behavior.
But this is not something like, because you were always talking about human behavior, this is also something that for us is sometimes very difficult when we come to a cultural context, because space means in Europe, in Western worlds, something very different to Asian context. So how do you transfer that also to machines then?
It is definitely a cultural aspect behind this. Just to take this simple example that robots, autonomous machines are already quite well accepted, for example, in Japan, whereas here people would be rather defensive against these machines in the wild. So yeah, it is definitely also bound to cultural context and aspect. So this intention is also very, very valuable to me, very important, because intention means that we can already say what the human is up to in the next step, and that would then allow a machine to better provide contextual options. For example, if the machine detects that this person is in distress, the machine could offer help, for example. The next important point is to enhance safety. Safety, especially for autonomous cars, is a very, very big chapter. And we have, I give this short example, a autonomous car drives along a street with a lot of pedestrians on the side. Now this car could then think that all these pedestrians are dangerous, possibly, to jump on the road, which would probably can bring the car to a complete stop. But it is important to differentiate whether these persons are just walking next to me, or there is this one person looking in the smartphone and stepping on the road. When I see this, I can immediately brake, and by that make sure that no accident is happening.
Well, there's a question coming in for connected to autonomous cars. So there's this data set from Google car and Apple cars, how humans react on average with these kind of machines. You have some knowledge about that?
I don't have any numbers on this reaction, but what we found out in many tests we did, I show this later, that it's very valuable for persons to understand whether the machine recognizes my presence. This is especially important for autonomous cars. In a normal situation with a conventional car, with a driver, when a pedestrian gets close with the intention to pass a road, the pedestrian would normally check for eye contact. with the driver. This is something that's missing. So for autonomous cars, there have to be, ways have to be found, of course, to kind of model this after the usual interaction. Regarding the technology that's required to achieve all this, is, as I've already mentioned, a variety of sensors usually necessary. Again, in some way remodeling the human senses. Yeah, we usually need to have a position for this machine to know where it is. We need to know in what direction it's looking. We need to have environmental information. Where are people at? We need to, as we already said, computer vision that would probably give us information about the stance of a person, in what direction it looks, how old it is approximately, because older people might not be that familiar with technology as younger would. And this is why I say we need a variety of sensors usually. We then apply multisensory techniques on this, which is a normal sensor fusion that we do, and then use this sensory information to interpret, to come to a decision, usually for a machine. And of course, as we've already said earlier, in sociological and cultural context. The design goals that always kind of drive our work is to say that such an interaction must be unobtrusive. We should not feel hindered by this machine. We would want to have it in a very natural way to interact, just as we are used to in a human-human interaction. We want to have it very simple. I do not want to learn new ways how to interact with this machine, just the way I'm used to with a human, and to make it very intuitive, this interaction. As a final related work that we did a couple of years ago with a car manufacturer, what I stated earlier a bit, is that we did a test setup where we wanted to get to know more about how persons perceive their interaction or getting close to an autonomous vehicle. And we came up with this bit playful environment here where we used like these autonomous ground vehicles that had various sensors around it and also lights as their main feedback source. We can see here the light, for example, this light ring here. We also used the projection to create various scenarios. For example, in one scenario, we had a situation where we had a crosswalk over a street, for example, and wanted to know how a test person entering here and intending to cross the road, how this person would react to these spots that were just going in circles around this spot. How would the person then know that this machine has correctly detected my presence and allows me to pass? So we came up with some sort of a sign language that we use this light strip where we can control the lights individually to shine a light into the direction.
Very like floor-based spots seems like where probably people will react differently than there would really a car be approaching them, because this seems like the thing where I just kind of step over it. Is this
it is rather reduced, yeah. So, which is again advantageous to have it built up, set up in a very reduced space. But still, we saw that people were a bit defensive in a first approach, because even though they knew the vehicles wouldn't be dangerous, wouldn't be able to hit them, it is still strange to step in the way of a machine that's going in circles there. So people were waiting a bit in advance, and we saw that this light that the vehicle had in the direction of the person helped actually a lot to lower this inhibit. Yeah.
Mm.
Yes, and that concludes the presentation. Thank you.
So thanks already for the, as I said, I put in on a couple of questions already during your introduction.
Mm-hmm.
One idea that came also in here from our viewers at home was with, like, in extreme cases, in the end, machines have better senses than humans. I mean, you have LiDAR system, you have radar, ultrasonic, things like that. Yeah. So is there like a potential to kind of elevate this, elevate decision making to post-human levels in terms of putting them even higher and kind of creating new spaces there?
Yeah, I mean, of course, this would be like, I would say, the holy grail of this whole research, to have all these sensors used to the most potential. But as we've already seen in the past, these machines and the decision makings are not free of error. And of course, the ambition in this is to use these sensors to the most potential, and also to make always the right or to derive the right decisions always out of this. Because of course, in an autonomous vehicle, if it makes a wrong decision, it most likely be a crash with injured, even worse. Yeah.
Is it important, this man-machine interaction in terms of space, how the machine looks like? Does it, like a humanoid-looking robot has to be behaving differently than like such a bot here?
It is, of course, very, very vital to come up with a proper appearance model for these machines. We have already seen that, for example, a very cute appearance also helps lowering this defensiveness against the machine. We've also seen that bots with a more like human autonomy, also very interesting for people. But of course, we know this phenomenon that's called the uncanny valley. Yeah? When we go a step too far and make this machine too human-looking, there's an immediate drop in acceptance, because this is something where people cannot really decide, is it still a machine? Is it already a humanoid? So there's this, people usually have a clear separation between.
But is this, I mean, coming to these kind of bots, when they look like that, I mean, when do you see, is there also this uncanny valley? Because they don't look human at all, but if they start to behave in terms of interaction too human, like they do everything I would from a human expect, is there also this uncanny valley in these kind of machines in terms of behavior?
I would not really see this. I would rather say there's the level of abstraction is too big. When we talk especially of this example here, everyone who saw the bots first was like, oh yeah, no, this is a vacuum cleaner robot.
Yeah,
so
I can kick him.
So people already have a model for this, and okay, this is this little machine that usually gets kicked around in your flat, for example. So this wasn't really an issue here, no.
Yeah, and you don't see that this, you know, this when they really would come to, you know, they start to play around even. I mean, because you were putting up this example of the vacuum cleaner and also the lawnmower. I mean, people start to kind of project intelligence into these machines, even though, I mean, particularly if you come to a vacuum cleaner, they don't have the intelligence that these bots have. But still, we already kind of give them, just because they kind of semi-autonomously move around, and if I step in there in their way, they just stop, because it's a very simple algorithm. So is there?
It is, in that case, I think this could, to a little extent at least, be achieved by the addition of that we would have these bots interact with each other. So that maybe they would stop and look at each other. Maybe then we could imply such a behavior.
And then I mean, also another question that I just getting quite interesting is I mean, errors are parts of human decisions, and of course, but at the same time, from machines, we don't expect to have any errors. So how do people really behave when, particularly you were mentioning, when an autonomous car makes a wrong decision, somebody can get hurt or can have some serious thing. So it's not accepted for a machine to fail. How does this, when it comes to this interaction, how is it like people who are first like open to a machine and say, well, it behaves nice, but as soon as it makes an error, everything breaks down in terms of the man-machine interaction?
Well, it's not good advertisement, of course, if such a wrong decision occurs. But yeah, given all this research that's going on in this field, we of course have to acknowledge the fact that that machines will always have their flaws, and they would appear maybe sooner, maybe later. But we should. I would say the best acceptance is obtained by this very natural interaction that I would see a machine close to me, and I would probably be a tourist in a city, and I would really approach this machine and say like, hey, I'm sorry, do you know where this and that street is? And this machine can give me an answer. This machine then doesn't necessarily have to look like a human in order for me to approach it. Yeah, we also work day and night on our computers, and they don't look very human. So I think this interaction is more the key to an acceptance. Yeah.
So I hope that your research helps to get this interaction even better. Thank you very much, Otto. I mean, one thing finally, because we were sharing the distance, and that's why we were putting on the mask right at the beginning, and we kind of forgot to take them off, but still we have a little bit of more than one baby elephant behind us. So I would like to ask to take off your mask, so at least we get a final image into your camera, into our camera. I think it's this direction here.
Hello.
So to finally have an image of you, Otto Naderer from the Ars Electronica Futurelab, here with us today in the deep space. So thank you very much for joining. And
thank you for having me.
Looking forward to see you at home in one of our future episodes of Inside Futurelab.
All right.
Thank you and goodbye.